what we're going to do is we're going to take up your Bohr-Rutherford diagrams. So if you can get your sheet out or your sketches out, and let's just take a look and see how you've done. Again, if you haven't got it perfectly perfect, no problem. We're going to fix it up as we go through. So you should have a sheet that somewhat looks like this. You guys had a sheet with a little bit more answers done for you on there to start off, but it should kind of look like this. So what I want you to look at here is, we won't go through every single element because that will take us forever, but we would just kind of want to look at the patterns. So what you should notice is here for your hydrogen, this is probably the hardest one, the hydrogen. Hydrogen atom, it has one proton, but it has no neutrons, 0 neutrons in the nucleus. Right, so we have one proton here. We skip over here to helium. We see we have 2 protons. Atomic number 2, 2 protons. We also have 2 neutrons. Then we skip down here to the other, back to the other side of the periodic table. We have element number 3, 3 protons. Next door to that, we have element 4. We've got 4 protons. Element 5, we have 5 protons, 6 protons, 7 protons, 8 protons, 9 protons, 10 protons, and you can see the same pattern as you go across the periodic table, that every time you go up by one number, you also go up by 1 proton as you go across. Now around the outside, you should also have your same number of electrons placed as you have protons. So in hydrogen, you should have 1 electron. Helium, you have 2, and remember that inner energy level can only get 2, so it's full. We jump over to element number 3. We now have 3 electrons around the outside, 2 in the inner, 1 in the outer. Beryllium, we have 2 in the inner, 1, 2 in the outer, so we have 4. 5 all together with 1, 2, 3 in the outer. For carbon here, which we were given the sample of, we've got 4 in the outer energy level, 2 in the inner energy level. Nitrogen, we have 1, 2, 3, 4, 5. Oxygen, 1, 2, 3, 4, 5, 6. And as we were placing them, we had to come around and double them up around these 2 spots here. When we get to fluorine, we've got in our outer energy level 1, 2, 3, 4. Then we had to come back and double up 5, 6, 7. And then we get to neon, we've got 8 electrons in the outer energy level and 2 on the inner energy level. So you should see that same pattern as you go along here. 1 in the outer energy level, then 2, then 3, then 4, and you'll notice that your 3rd energy level all the way across here is completely filled with electrons up to 8, and the energy level are completely filled with 2 electrons in each of those. Right, so if you have one that looks very similar to this, great job. Check the spelling on your phosphorus, check your spelling on your potassium, it's P-O-T, potassium, and also check your spelling on your fluorine, this F-L-U-O-R-I-N-E, all right, so fluorine. Now what I want you to do with your periodic table is, we're going to do some numbering. Right, so we're just going to take this, and what we're going to do is we're going to number the rows. We're going to number the rows from the top to the bottom. So your first row here is number 1. This is your first row all along here, all right? And I know there's nothing in here, but that's just how the periodic table is set up. And then our second row in here, 2. Now remember this deep line here, all right? This is the split where we're going from one side. We only want to do the first 20, so we're going to go from one side of the periodic table. We're going to skip all the transition metals in the center, and we're going to go over to the right side of the periodic table. Our next row here is row 3 and row 4. So while we're doing this, now there's a sheet you can be using to fill this out, or you can just answer this on your own sheet. So it doesn't matter how you do this. So the question is, what do you notice about the row number and the number of energy levels as you go across the periodic table? So you don't have to answer this yet. We'll do it on the next slide. But let's just take a look here. Here's the row number. Let's just look at 2. Make life easy. All right? Number of energy levels all the way across. What do we notice here about the row number and the number of energy levels? I know it's a pretty easy answer. Let's look at row number 3. How many energy levels do we have as we go across here? Very interesting. And how about 4? All right, and then the next question I'm going to ask is, what do you notice about the number of electrons as you go across the rows of the periodic table from left to right? Well, we've kind of touched upon this already, right? So as we go across the rows, we notice that we also go up in numbers. So this guy here had 3 electrons. Now we have 4 electrons, then we have 5 electrons, and now we have 6 electrons. I'm going to ask you one extra little question here though. What do you notice about the number of electrons in that outer energy level? Because that outer energy level is going to be very, very important as we go through here. All right, so this is an extra little question I'm asking you in here. What do you notice? Well, we have 1 here, right? 2, 1, 2, 3. As we go across, we tend to go up a little bit more. So let's look at the answers to these questions. So first question, what do you notice about the row number and the number of energy levels as you go across? Well, the number of energy levels is the same as the row number. So from left to right across that periodic table, if you are in row 3, you're going to have 3 energy levels across every element in that row. Next question, what do you notice about the number of electrons as you go across the rows? Again, you notice that the number of electrons goes up by 1 as you go from left to right. And also keep in mind that those outer energy levels, or the electrons in the outer energy level, also are they're the ones that go up by 1. So the electrons increase by 1 as you go across the periodic table. Next thing we're going to do is look at your periodic table. All right, you've got your row numbers down here, right? I just took them off for this because I wanted it to just concentrate on one thing. And we're going to number across. So this column or group, we're going to say that the columns are groups. So this group is group number 1. This group is group number 2. Now, remember, we're going to skip all the ones that were in the center of the periodic table. We're going to skip over to the other side because we just want to do the first 20. So we're going to number this next guy as number 13. And then 14, 15, 16, 17, and group 18. So that's how these guys are going to be grouped. Group 1, 2, and then 13, 14, 15, 16, 17, 18. Now pay very close attention to that ones number in there, the number that's in the ones column. That's going to be very important for us coming up. Not even kidding. So what do you notice about the number of energy levels as you go down the group? So as you start at the top and you go down, what do you notice about the number of energy levels? And keep in mind as well, we're not going to ask this question formally, but what do you think happens to the size, or what happens to the size of the atom as you go down? Alrighty, and the next question is, what do you notice about the group number and the number of electrons in the outer energy level? Because remember we said those outer energy level guys are going to be very, very important. So let's look at our answers. So first question, what do you notice about the number of energy levels as you go down the groups? Well, the number of energy levels increase as you go down the groups. And just to add this in here, it's not on this here too, but did you notice how much bigger the actual atoms got as you added more energy levels as you went down the rows? So that's going to be really important. And what do you notice about the group number and the number of electrons in the outer energy level? Well, the number of electrons in the outer energy level is similar to the ones in number. I can't go back on this, but if you go back and look at your picture, you'll notice that in the group number 1, there's 1 electron in the outer energy level. If you look at group number 2, there's 2 electrons in the outer energy level. If you go to number 13, 1, 3, there's 3 electrons in the outer energy level. If you look at 14, 1, 4, 4 is in the ones column, there's going to be 4 electrons in the outer energy level. For group 15, there's 5. For group 16, there's 6. For group 17, there's 7. And for group 18, there's 8. So that's going to be really important for our next topic that we're doing, and it's going to help you understand how compounds form. So why does sodium and chlorine hook up together and make sodium chloride? That's going to be really important, looking at those outer energy levels and looking at those electrons. So all you have to do for this is do the quiz. You don't have to hand anything in. Have a great day.